Hey, hi everyone. Welcome to the session of developer experience. So, as part of your software development, you'll be doing coding. But just keep in mind, the coding will not be happening in silos. So, as part of your learning the programming language, you might be just taking your laptop and then working on it. Like you install a PyCharm. I'm talking about the Python developer experience. So, either you have a PyCharm or you have a Jupyter notebook and you start coding there. But just keep in mind, like in a real project, you will not be the whole and sole developer running that project. There will be so many people, and the number can go up to even like thousands of people working on the same project. So the question arises, how does the developer experience looks like? How does the code that you develop on your personal laptop reach all the way to the infra part wherein it gets deployed? So this session is more about how the collaborative development is happening. What are the different tools required? If I want to use some shared lib that I can share across the world because that lib is reusable, how can I do that? How does my code gets deployed on the production? Though I am developing my code locally on my machine. And what is the experience looking like for Java, Python, and the IDE, the integrated development experience that you get? What are the different tools and services out there? My name is Kunal Gautam. I work as a principal architect in one of the man companies having 16 plus years of experience. Had my own startup and have spoken at multiple big data and AI/ML conferences around the globe, namely Budapest, Korea, Germany, US, India. Let's go for a quick deep dive into it. So this is in general, this is completely uh, programming language agnostic because this is talking about the process and the capabilities you need to have in the system to get your solution deployed end to end. So just like at high level, the capability perspective, you have a code repository like a GitHub or GitLab. Then you have a central artifactory, which is again a service wherein you can host your libraries. You can develop and build something, and the library gets pushed and gets stored on the Artifactory part of it. Why is this? Example, Meta came out with PyTorch, and it realized that PyTorch is required by most of the machine learning professionals around the globe. So they open sourced it, but the question was, how do they take this PyTorch library and ensure that it's accessible to everybody in the world? So the same idea, like go to a place, have a fixed defined contract, have a proper documentation of how to use it, and host it somewhere. So that rest of the folks can just connect to that server or the application server and download it from there. So again, the same idea, central repository, contract, everything documented, no manual intervention by exchange of this information. It should all happen with APIs and the clients of that. So what happens is when Git and GitLab provide a service, they also provide an appropriate client of how to connect with Git and GitLab. Similarly, if you have an Artifactory, in case of Python, you have PyPy, JFrog. In case of Java, you have Sonatype Nexus kind of solutions out there. The file format that is saved in the Artifactory of Python is an egg file, wheel file, or a zip file. While in case of Java, it's a jar file. We'll go into the details, but just from the perspective, think about like how this is happening. Now the part is, sorry, your developer ID. So this is your local computer. So what's happening is as the first pass, either your repository had already been created in the code repo because a lot of people wanted to collaborate together to get this repository up and running. Somebody was working on the database part, somebody was working on the UI part, somebody was working on the transformation part of it, somebody was working on the ingestion part of it, somebody was working on the application interface part of it, the API layer part of it. So there were different personas who were working in, and everybody wanted to go ahead and contribute to the project so that you meet the timelines and everything is checked in a central place so that in case your laptop crashes, your code is already saved somewhere. You don't lose the code. Secondly, these repositories, they also give you a standard of how to write the code, when the code can be released, what are the different linting process out there, when the code will be built, what mechanism will be leveraged to do the code build. Code repositories provide all this capability out of the box. So again, as part of your personal development ID, you are using either a PyCharm or IntelliJ for Java, PyCharm for Python, or a Jupyter Notebook for Python, right? So you install that, you open your laptop, you install this service, and then you get started. The first one is, first of all, you have to download the repository from your code repo, because this is hosted, let's say, somewhere in Mexico. You are sitting in India. So I cannot go and code in Mexico from here, right? What I can do is I can download the file or the folder from my Git. How is that done? Git provides a CLI known as Git, and Git CLI has multiple uh, parameters that you can pass. Example, Git clone. What Git clone will do is whatever is the folder structure in this code repository, it will just copy everything and create a similar folder structure locally on your machine. Yep. If you have made some changes and you want to push it back to the code repository, then you can do a git push. Yeah. Similarly, the same thing goes for us, and the different configuration file that we require in Python is requirements.txt and the setup.py. We'll speak about that. For the packaging part, in Python, there is also a format known as the TUML format. So setup.py and TUML, like they are competing solutions for your packaging your Python libraries. Java has Maven, and the Java package is a jar. So once you have done your development, if the code is usable, you can also push the code to the Artifactory here. First, sorry, let's go line by line. So first, you do a git pull. So from your code repository, things go onto your local machine. You do the local development, and then for the local development, you might require external libraries. That's the reason in requirement.txt, you provide the library name equals to minor comma dot major comma dot minor version. And that's how you ensure that the library that you require gets downloaded from the Artifactory onto your local machine. Once you're done with your code development, everything is good, you check in the code back onto your GitHub, right? Then you have a Jenkins build. This is nothing but like an EC2 instance or a laptop, wherein it connects to your GitHub, it connects to the Artifactory, and then builds your code here. Once the code is built, like if you want, it can also be pushed back onto the Artifactory if you require. If not, there is no hard and fast rule. If you realize that, hey, only 2 people are using my code, I don't want to push it onto Artifactory, which is PyPy, or your custom Artifactory like a JFrog that you have installed in your enterprise. So you might choose not to push it back onto the Artifactory. And this Jenkins build tools, as part of its code, it can either go ahead and deploy the solution, your Python code, in a similar setup as your local machine on cloud. So either it can be AWS, GCP, Azure, your private data center. It spins up let's say a small computer out there, which is known as the EC2 instance, Elastic Cloud Compute, and then it deploys your Python program here and executes that. If your Python program happens to be an application server, it will keep running 24 into 7. How to visualize that? Let's say in your Python code, you have a while loop, infinite while loop. It means that the Python code is running 24 into 7 now. That will never die. And the different tools for this is also known as the DevOps, or this continuous integration, continuous deployment. As and when you push the code here, the code gets deployed on the cloud automatically. So you are doing incremental merges from your ID onto the Git. From your Git, the Jenkins build tools keep popping up because it's a event-driven kind of building process now. So the moment you push a code, the code goes here, and there's a branching strategy on the GitHub. Like we don't want to delve into that at the moment, but just keep in mind there are branching strategies out there. So Git can have 3 branches, one for each environment. So the QA for the QA environment, dev for the dev environment, main for the prod environment. Let's say you push the code onto the main branch. The moment you push the code onto the main branch, it will automatically go. The Jenkins build will trigger, go pull the code from your GitLab and the dependencies from your Artifactory, and go ahead and push the code on the cloud. This part is known as DevOps, or also continuous integration and continuous deployment. Deployment means pushing to prod. Integration means as and when you are pushing the code to your Git, this process, arrow number 3, 5 should get triggered. There are various, again, programming languages, or let's say scripting languages, to help and support you with your DevOps, which is known as Terraform or CDK. So again, I would just love to take a pause here for you to appreciate the fact This code repository, this artifactory, these are nothing but application servers running somewhere in the world. And they have abstracted out either the hard disk or the database. So let's quickly look into this three-tier architecture, because this will keep popping up again and again, and it will also provide you a very good mental model to understand how to visualize this GitLab. Like, what is this GitLab or GitHub? What is it exactly? So this is basically the architecture of any service which is hosted remotely. Pretty much this remains the same. What can happen is this database might be replaced by a file system. This database can be replaced by a cache. This database can be internally replaced by another API. So what this architecture says is, first of all, you have a client. The client can be something like a workbench is a client. Git client is there. Then it says that, hey, there will be an application server. What's an application server? So application server, if you would have gone through the socket programming, these application servers are listening on a particular socket so that they can be placed remotely. And the protocol on top of it is like a REST endpoint, HTTP, HTTPS, FTP, whatever that service provides. Whatever the application provides. That's the kind of application you are writing. This application can be written in Java or Python. How in Python? Python has a fast API library. And again, as I mentioned, every solution provider will provide you artifacts of how to use it. So the fast API, if you go to the documentation, this is the official documentation of fast API. It says where is the source code, where is the documentation. And again, if you just scroll down, it will give you a very simple one that, hey, if I want to create a like a hello world kind or a very simple API interface, just by using these 5 lines of code, you are good to go. Right? How to execute it, check it, blah, blah, blah. Right? So that's how you're able to create, let's say, a Python application program. And this application program runs 24/7 so that people can connect to it 24/7 and get your work done. This is not known as a middleware. And again, this can now, because it's a code end of the day. Now you can connect to a database internally, or you can connect to, and again, database internally in the sense that you connect to a database programmatically, not through the CLI, not through the UI. This Python program can connect to your database programmatically. And that's how you get your work done. So be it your GitLab, be it your, what's that? Artifactory, Google.com, Amazon.com, this all follow the same architecture because end of the day, they are all hosted remotely. So this layer remains as is. What is happening is this layer keeps changing depending upon what you're doing. All right. So first of all, we'll quickly go through like just some callouts. The code repo Git can be used for both Java as well as Python. Secondly, Python has its own artifactory. Few examples are PyPy, and PyPy can store file formats like wheel, egg, and zip. Are there other artifactories? Yes, something like a JFrog. Python also says that locally you have to create a virtual environment. The reason being, Python doesn't allow two versions of the same library to be installed. Example, if I am using simple JSON, there are two versions, simple JSON 2.1, simple JSON 2.2. What Python says is, I will only allow the last, whatever you have installed the last. It is not even dependent upon the version. Whatever you have installed at the last, that will override all the previous versions. So what it means is, if I have two libraries and both of them requires like simple JSON 2.1, the other requires 2.2, and I'm running both my repositories on my same laptop. And if I share the library folder structure, then what will happen? If this is using 2.1, it will install 2.1 here. It is using 2.2, it will install 2.2, and now 2.2 will override everything. So even your first project will start seeing 2.2, and then it will fail because it had a dependency on 2.1. So what virtual environment says is, create that library, the dependency library folder separately. And that's what you're doing in virtual environment. You are saying that two projects, both of them would be having different virtual environments, as in different folder structure completely, so that this conflict doesn't happen. And this is very unique to Python. In case of Java, Java can support multiple versions in the same lib, same folder. And that's the reason in the Java world, just like you had the Artifactory PyPy, you have Sonatype Nexus. Here you have the file format as wheel, egg, and zip. In case of Java, it is a jar. And Java has the project type Maven and Gradle. And both of these projects, they can share the libs. So the folder structure is .m2, and multiple versions of the same library can exist there, which is not the case with Python. And that's the reason you have virtual environment concept. And for even for virtual environment, you can use the tool like VNV or Anaconda to achieve that. I have just given the links of few of the stuff here so that you can just go through it and create your mental model. Yeah. Now, so quick one. Let's get started. Just first of all, just to see like, hey, what's where and how it's there. So see, this is my Git repo. You can go here, log in, create a profile. You'll also be asked to install the Git CLI. And Git CLI will have its own usage. It will have its own verbosity and its own parameters of how you have to operate it. It will all come by. I'll leave this task on to you just to understand how to create go to this website, github.com, create a profile, create a sample repository, and download that locally. And download doesn't mean you're downloading it from here. You have to download that using the Git client, right? So first thing I want to show, Git can host both Java projects as well as Python projects. So this is my neural network Python project written using PyTorch. If I go back to my repository, this big data is a Java repository. So it means that Git as such, it's completely transparent what you are hosting there. It simply means that this is abstracting out your file system using the application layer logic. Because on the folder, on your just like, sorry, on your data storage that it is abstracting, you can save pretty much anything, or even an audio file you can save. It doesn't care because Git has no understanding about it's a Python project or a Java project. All right. Then this is the now we are just this is the artifactory of Python, wherein you are building some code, you are converting that to a wheel or an egg file, and you want to push it to a global place so that everybody can use it. This is the PyPy. So Python file index. So it is indexing all the libs that you have here. So now you start correlating in your requirements.txt file, whatever you are placing, it pulls it up from here and downloads that locally on your virtual environment. Similarly, for Java, you have your Sona type, which is the Nexus repository, which pretty much looks like this. So you can go here, you can say that, hey, I want to have a dependency for developing my code, and you download the dependency from here by having just this block of the code added into the pom.xml file. There is also a standard for writing your documentation, which is known as readme.md. Just keep in mind, folks, readme.md again has its own nomenclature, own syntax of how to write, and this is how you write a readme.md file. So this describes about the project that you are building. Next, what is a wheel file? So this document just speaks about what is the format of the wheel file, why it is used, what was the pros and cons, how to use it, not to use it, all the, let's say, the best practices out there. This is one of the artifactories, just like you had PyPy in Python. JFrog is another artifactory that can be used to save your libraries and then can be reused across your organization or, if required, across the world. This is the documentation for jar, that just like in Python, you have the wheel file and the egg file. In Java, you create a jar file, which is like packaging all the code binaries that you have, code and binaries that you have, depending upon how you have configured it. And this is the jar file that gets pushed onto the Maven Sona type. All right. And Python has Maven projects. Python can have a Gradle project. So this is the Gradle understanding of it. Let's quickly go on to the code. So first of all, I just want to show you, this is my Python code. In my Python code, oopsie, it got hung. Let me just stop. And let me just reshare again. Huh. So now, folks, this is my Python project. So you have your project. These are, let's check here, Python packages. Why do I say that? You see the small dot here, PyCharm specifies that this is my, once again, this is my Python package. Why is it? Because this Dundee underscore int underscore dot py says that this is a Python module. So what happens is, if it's a Python module, I can import that in my code, like from LLM something something something. Just look at this here. What is LLM GPT? This is LLM GPT dot pre-training dot pre-training. So you see here LLM GPT. Again, the sub package is pre-training, then pre-training tokenizer. One sec. Pre-training and yeah, pre-training and tokenizer, right? So here, pre-training, then tokenizer, and then you can call the functions here. So that's how you're able to navigate if you have your Python sub modules placed everywhere. Okay, now getting back to the topic. What all things? So this is in general. Like if you look till here, most of the folks are able to develop the Python package till here. Now some more interesting configuration file. One is the requirements.txt. So you see here, whatever libraries I'm dependent upon, it's all saved here along with the version. That's super important because you just want to ensure whatever versions you have created the code and tested that on your local laptop, the same version should be available for the build, or the same version should be available for the other developers to work on this project uh, collaboratively. So you have to provide the lib name and the version number. How do I get the lib name and version number? Example, I just go to PyPy and I just search for JSON example. Yep. If I just click here, it will tell me what is the version, latest version number, and what are the previous versions numbers also. You can do a quick Google search and it will tell you all the previous versions number. And based on that, so you can see here 0.4.3, 4.2, 4.1, 4.0. You can click on any of them. It talks about, hey, what has happened, what are the new features that arrived on this specific version. That is how you are able to figure out which version to use. So you provide the version number. Once you provide the version number, you have to install them, right? Because so that your virtual environment, this is my VNV project, right? How do I know that it's a VNV project? Because if you see here, the configuration file name is pyvnv.cfg. Because when I created the project, this was a virtual environment. And that's how I'm able to figure out, hey, this is a virtual environment project. I'm not claiming it. I'm seeing this file and then making a claim. So requirement.txt, you have written everything. How do you go ahead and install? What it means is take all the libraries from your Artifactory, install it locally. How do you do that? There is a command, pip install -r requirement.txt. So whatever you do here, the moment you type it, it will go ahead and download all the libs that you see here in your bin or lib folder comes up. Sorry, lib folder here. All right. So whatever you have written here, all of them gets downloaded in the lib folder. And this lib folder is part of your Python folder path. So it ensures that if you are referring to this lib, Python interpreter is able to find the lib end of the day, right? Then another tool, setup.py. That fine, I'm able to fulfill all my dependencies. I'm able to write the code. The next thing is, hey, I want to package that as a egg file or a wheel file. What should I do? So now, as I mentioned, there were two competing technologies or two competing solutions. One was setup.py, one was TOML. Look for TOML. This I'll provide a sample of setup.py. So you go here. This is how you write a setup.py. So first of all, this is the block, important block. You say that this Python code requires 3.12. It means that when I had created this Python module on my local machine, 3.12 Python version was there. So now what it says is anybody who has to download this folder, they can Python project, they can go here, figure out what is there, and they can change their version to 3.12 so that your development environment versioning and the other person development in person or the Nexus, person or the Jenkins, they are at the same version so that nothing breaks. right? You fulfill the name, version, the git, blah, blah, blah. And here is the interesting part. See, the install requires is requirement.txt. So I'm opening the file requirement.txt, reading everything, and pushing it into the installer requires. So what happens is when I execute the command to create a will, it will look at all these libraries and it will package that together in the wheel file. How can I do that? So this is the command. Yeah, Python setup.py bdist will. So the moment I execute this, it went ahead and it created the file. All right. Where can I see that file? Yep, dist, distributed. So there were two folders created. It took a while to read it from the disk and show it onto the PyCharm. And you can see here the wheel file has been created. In case I want to push this wheel file onto PyPy, how can I do it? So here is the command. You have to install Twine first of all, and then you can say Twine upload dist star. So this is nothing but this folder. Whatever is inside here, it will get pushed to PyPy if you have the profile there, right? Again, if I want to create an egg file, just like I typed in the command b python setup.py bdist underscore v, I can go for bdist underscore egg. If I don't give anything, only as this type I provide, it means that it will create a zip file for me. So just keep in mind, why was this packaging required? So that the Python code, this py files that you have in your sub modules, example, whatever, LLM GPT, right? So these, along with the libraries, they are packaged together and sent for somebody to use. So that when the other person uses it, they have an understanding what is the version number or what was the dependency version number required. And the Python code is anyhow present as part of that uh, packaging file, which is egg or wheel, and it all goes and sits at one place. So this ensures that repeatability is there. The way you have coded, the environment, the version it is there, the other person will get exactly the same copy of it. And again, remove the human communication. Rather, everything is part of your code base. I don't have to speak to the developer in order to understand what needs to be done. I can look at this configuration file and ensure that, hey, these are the library versions required for me. Another important thing I want to show that this project is part of the Git. So Git also provides you a Git ignore folder for file. What it says is whenever you're pushing a code onto Git, let's say for example, I don't want to push this wheel file in my Git because wheel file should not stay in Git. Wheel file should either stay locally or should go to your artifactory. So whatever folders you give here, that will not be part of your Git push command. So whenever you do a git push command, it will first of all figure out, hey, if it's present here, not to push that code or lib onto your artifactory. Sorry, onto your Git. Very quick one, folks, that this is an IntelliJ project. Now you can see here, it's also being pushed onto Git itself. But just I want to show, just like in Python, you had requirement.txt and setup.py, you have POM here. This is a Maven project. And as you can see in the requirement.txt, we were giving the lib versions. Here also you do the same thing. That this is my dependencies. And at the very end, it will talk about how to package it, how to create the jar file out of it. So this is my plugin, which says that how to create a jar file out of my code plus the uh, the compile class of the Java. So that's how it works end to end. What I love is you folks take a pause, especially for this part. Think about it, how the flow is there. You are developing locally. Your virtual environment is local. In context of Python, you are connecting to the remote repository, which is the code Git repository, getting the code, doing the development, pushing onto Git. Once you have done the push, if you require any dependency, requirement.txt connects to the artifactory, downloads that for you so that you can do your deployment. Once once development, once you are able to push the code back to the code repository, The code can be picked up by the Jenkins ones, which is one of the DevOps tools out there. The different companies have different tools. Jenkins is just one of them. It pulls out the code, pulls out the dependency from the Artifactory, generates the code, setup.py is there, a wheel file can be created. Depending upon how you have configured, it can be again pushed back to Artifactory or it gets pushed onto the cloud. So that's the overall flow and the developer experience that you have. Start thinking about what you have been doing and how all of this correlates in the ecosystem. Hope to see you in the next session. Thanks a lot. And it was an amazing time creating and sharing this with you. Thank you.